afternoon, Sir Boris Torres. I am Angelo Benedict Agi from BSTM 1A, and I am from Group A. And I am here to present the topic Measures of Position. Introduction. The purpose of measures of position is to help us understand the relative location of a particular value within a dataset, showing how it compares to other value in terms of magnitude, frequency, and spread. The primary measures of position are percentile, quartile, median, and z-scores. Let me explain about percentiles. Percentiles divide a dataset into 100 equal parts, helping to understand the distribution of data by indicating the relative standing of a value within the dataset. The key points here is the ninth percentile is the value below which n% of the data falls. For example, the 90th percentile indicates that 90% of the value are below this point. Example, in a class of 100 students, if your score is at the 80th percentile, this means you scored better than 80th% of your classmates. Number 2, quartiles. So, quartiles divide data into 4 equal parts. These include the first quartile, Q1, median, Q2, and the third quartile, which is Q3. The key points here is Q1, lower quartile, the median of the lower half of the data. Q2, which is median, the middle value that divides the data into two halves. And lastly, the Q3, which is the upper quartile, the median of the upper half of the data. So we have interquartile range, which is IQR. The IQR is the difference between Q3 and Q1. It shows the range where the central 50th percent of the data lies. Example, a dataset of exam scores might be divided into quartiles. Q1 is the score below which 25% of the students scored, and Q2 is the median, 50%, and Q3 is the 75th percent of the students scored below. So let me explain the third one, which is median. The median is the middle value of a dataset when arranged in ascending order. It is a robust measure of central tendency that is less affected by extreme values or outliers. The key points here is if the number of data points is odd, the median is the middle value. If even the median is the average of the two middle values. Example, for the dataset 3, 7, 9, 15, 21. So the median here is 9. So let's move on to z-scores. A z-score measures how many standard deviations a data point is from the mean. It is useful for our comparing values from different datasets with different units or scales. The formula here is z is equals to x minus um, the mean of the dataset divided by the standard deviation. Interpretation. A z-score of 0 means that the data point is exactly at the mean. A z-score of 1 means the data point is one standard deviation above the mean. A z-score of -1 means the data point is one standard deviation below the mean. Example, if a student scored 85 on a test with a mean of 75 and a standard deviation of 5, then z-score would be z is equals to 85 minus 75 divided by 5, which is equal to 2. This indicates that the score is 2 standard deviation above the mean. So the conclusion here, my topic is the measures of position provide valuable insights into where specific values stand within a dataset. They will help us to identify trends, patterns, and outliers. Thank you.
Christian Bronio. I'm here to discuss the measures of variation. Variance is a measure of how data points differ from the mean. According to Lehman, a variance is a measure of how far a set of data numbers are spread out from their mean average value. Variance means to find the expected difference of deviation of actual value.
My name is Jasmine Simon from BSTM1, and I was assigned to present about the four main types of measures of variation. And now, let's proceed to the four main types of measures of variation. So, the four main types are range, variance, interquartile range, and standard deviation. For the range, it is the difference between the highest and lowest values in a set of data. And for the variance, it is the average of squared distances from the mean. So for the variance, it is similar to standard deviation, like it measures how spread out of the data is from the mean. And for the interquartile range, it is the range of the middle half of a distribution. So for interquartile range, this means that you find the middle 50% of the data and then calculate the difference between the highest and lowest values in the middle 50%. And for the standard deviation, it is the average distance from the mean. So for the standard deviation, it measure of how spread out the data is from the mean. Like it tells us how much the data points typically differ from the average value. And now, let's proceed for the examples. For range is to find the range, simply subtract the lowest value from the highest value in the data set. So for example, you have 8 data points from sample A, and the highest value is 324, and the lowest value is 72. So the range of your data is 252 minutes. Maybe some of you thinking why it is 252? It is because if you minus 324 to 72, then your answer will be 252. So actually, for me that is the very easy because you just need to minus the highest value to the lowest value and now you will get the answer. And for the examples for variance variation, suppose we have the data set 3, 5, 8, and 1, and we want to find the population variance. So the mean is given as open parenthesis 3 plus 5 plus 8 plus 1 divided by 4 is equals to 4.25. So it is 4.25 because if we add 3 plus 5 plus 8 plus 1 is equals to 17, then 4 because the total of our data set is 4. So 17 divided by 4 is equals to 4.25. And by using the definition of variance we just need to copy from our data set and then divided by it by the total that we get earlier, which is 4.25. So open parenthesis and then 3 minus 4.25, and then as you can see that there is a number 2. It means that you just need to times it by itself. So 3 minus 4.25, that will be equals to negative 1.25, and then that negative 1.25 you just need to times it by itself. So negative 1.25 times negative 1.25 is equals to 1.56, and then for the second 5 minus 4.25 is equals to 0.75, and then we just need to repeat what we do in the 3 minus 4.25. So 5 minus 4.25 is equals to 0.75, and then 0.75 times 0.75 is equals to 0.56. For 8 minus 4.25 is equals to 3.75, and then 3.75 times 3.75 is equals to 14.06, and 1 minus 4.25 is equals to 3.25. So 3.25 times 3.25 is equals to 10.56. So after we get the total, after we times it by itself, we just need to add all the totals. So for the totals, we just need to add 1.56 plus 0.56 plus 14.06, and 10.56 is equals to 26.74, and then we just need to divide it by 8 by the total of our data set, which is 4. So 26 for 0.74 divided by 4 is equals to 6.685. So here is the examples for that. So it's easy, right? You just need to study it carefully for you to know the correct answer. And for the examples for interquartile and the standard deviation, that will be given to my another member. So that's all for today. Thank you.
Hello everyone, my name is Katrina Pio from BSTM 18. I'm here to discuss on how to calculate standard deviation. Data set 70, 75, 80, 85, and 90. We will follow an example to make it easier to understand. Imagine we have a data set of the following test score: 70, 75, 80, 85, and 90. Step 1. Find the mean. That's just the average of all the scores. Add up and divide by the total number of scores. Step 2. Subtract the mean from each score. This tells us how much each score divides from the average. Step 3. Square each deviation. We square them to get rid of negative values and emphasize the differences. Step 4. And the mean of the square deviations. This is called the variance and measures average dispersion of the scores. Step 5. Take the square root of variance. This final step, it gives us the standard deviation. For the interquartile range variance, we will have example given data: 23, 22, 24, 15, 30, and 34, 31, 22. To find range, interquartile range, sample variance, and sample standard deviation. Step 1. To find range, let us order the data from smallest to largest. 15, 21, 22, 22, 23, 24, 30, and 34. Range, largest value, negative smallest value. And it's short for 34 minus 15. And the range is equals 19. And step 2, find interquartile range. Interquartile range is third quartile, negative first quartile. Quartile adjusts median of different section of the data. Quartile 1, median of the first half of data. Quartile 2, median of second half of data. And quartile 3, median of all data. Provided data must be ordered from smallest to largest. There are total 8 data points: 15, 21, 22, 22, 23, 24, 30, and 34. Quartile 1, median of first half of data. Median of data is 15, 21, 22, 22. Equals to 21 plus 22 over 2. And we will subtract the 21 plus 22 is equals to 21 plus 22. We will divide it to 2 is equals to 21.5. And for the quartile 3, median of second half of data. Median of the data is 23, 24, 30, 34 is equals to 24 plus 30. We will add them, and the answer, we will divide it by 2. The answer is quartile 3 equals to 27. The interquartile range equals to quartile 3 minus quartile 1 is equals to 27 minus 31.5, and the interquartile range is 5.5.